Hello, my name is Adams, and this is my assignment 4. For this assignment, I created an interactive Java console application for the IS Cyber Defense Operations Center. The purpose of this program is to allow Security Manager to add, view, sort, shuffle, and analyze incoming network security alerts. The program also uses object-oriented programming, generic collections, exception handling, custom exceptions, and file input and output. Our project contains 3 Java files: security.java, invalid threat level exception.java, and alertmanager.java. Begin with the security alert class. The security alert class represents one security alert in the system. Each alert has 3 pieces of data: an identifier, a source or description, and a threat level. The identifier is stored as a string. An example would be inc-1. The source is also stored as a string. This could be something like main database server or a suspicious login attempt. The threat level is stored as an integer between 1 and 10, and where 10 represents the most serious threat, all 3 fields are declared private. This demonstrates encapsulation because the data cannot be accessed or changed directly from the outside class. Instead, the class provides getter methods called getIdentifier, getSource, and getThreatLevel. The constructor receives the identifier source and threat level when a new alert is created. Inside the constructor, I check whether the threat level is less than 1 or greater than 10. If it is outside the valid range, the constructor throws an invalid threat level exception. If the threat level is valid, the constructor stores the values in object private fields. Security alert class also implements the comparable interface. I used comparable security alert because the assignment requires the alert objects to support natural ordering based on threat level. The compare to method compares the current alert's threat level with another alert's threat level. I use integer.compare to perform this comparison. If the current alert has a lower threat level, it will appear before an alert with a higher threat level when the list is sorted. This creates ascending order from the lowest threat level to the highest threat level. If 2 alerts have the same threat level, I compare their identifiers alphabetically. This gives the program a constant ordering when 2 alerts have equal threat levels. The final method is the toString. The purpose of the toString is to control how security alert object appears when it is printed. Instead of printing a memory address, the program displays the alert identifier, source, and threat level in a clean formatted line. This file is invalid threat level exception.java. This is a custom exception class. It extends Java's exception class, in which makes a checked exception. The constructor accepts a custom error message and passes it to a parent exception class using super. I created this custom exception because the assignment specifically requires the program to reject threat levels outside the range from 1 to 10. Using the custom exception makes the error more specifically and easier to understand than using a general exception. The third and main file is alertmanager.java. This class contains a main method and controls the entire program. At the top, I imported several Java classes. I imported ArrayList to store security alerts. I imported collections so I could use the required algorithms, including sort, shuffle, min, and max. I imported scanner to receive input from the user. I imported input mismatch exception to handle cases where the user enters text instead of numbers. I also imported formatter and file not found exception for creating and writing the threat log level. Inside the class, I created a constant called log file name. Its value is in threat underscore log.text. I used a constant so the file name is stored in one location and can be reused without repeatedly typing the string name. Inside the main method, I create a scanner object called scanner. The scanner reads input from the console. I also create an ArrayList security alert called alerts. This is generic ArrayList, meaning it can only store security alert objects. Using the generic improves type safely because Java prevents other types of objects from being added accidentally, It also means that I do not need to cast objects for retrieving from the array list. Next, I create a boolean, a variable called running, and it's set equal to true. This variable controls the interactive command loop. The program first calls print welcome message, which displays the title of alert management system. Then the program enters a while loop. The loop continues as long as running remains true. At the beginning of every loop iteration, the program calls print menu. This method displays all available commands. The commands are add, view, sort, shuffle, extremes, and done. The program that asks users to enter a command, the command is read using scanner.nextLine. I also use trim to remove any accidental spaces before or after the command. The program uses a switch method to determine which actions should be performed. If the command is add, the program calls the add alert method. If the command is view, it calls view alerts. If the command is sort, it calls sort alerts. If the command is shuffle, it calls shuffle alerts. If the command is extremes, it calls display extremes. If the command is exactly done, the program saves all alerts to the file and sets running equal to false. This causes the while loop to terminate. If the user enters an invalid command, the default section prints a friendly message explaining the available choices. I will now explaining the add alert method. This method receives a scanner and the array list as parameters. The program first asks the user for an alert identifier. If it's red, identifier is a string. If the identifier is empty, the method prints an error message and returns to the main menu. The program also calls the identifier exists method to check whether the identifier is already being used. This ensures that every alert has a unique identifier. If the identifier already exists, the alert is denied. Next, the program asks if for the alert source or description. If the source is empty, the method also denies the alert and returns to the main menu. The program then enters a try block and asks the user for the threat level. The threat level is read using nextInt. After using, I call scanner.nextLine. This clears the leftover new line characters from the scanner. Without this line, the next string input could be skipped. The program then attempts to create a new security alert object. If the threat level is valid, the program object is created and added to an array list. The program prints a success message and displays the new alert. There are two catch blocks in this method. The first catch block handles input mismatch exception. This occurs while accepts an integer, but the end user enters a text such as severe. Inside this catch block, I call scanner.nextLine to clear the invalid input. The program displays a friendly message, safely returns to the main menu. The second catch block handles invalid threat level exception. This occurs when user enters a number outside the range from 1 through 10. For example, entering 0 or 15 would cause this exception. The program caches the custom exception, prints its message, and denies addition. The identifier exists method uses for each loop to examine every alert in the array list. It compares each identifier equals ignore case. This means identifiers such as inc-1 and lowercase inc-1 are treated as duplicates. If a match is found, the method returns true. Otherwise, it returns false. The view alerts method displays all alerts in their current order. It first checks whether the array list is empty. If the list is empty, it prints the message saying there are no active alerts. Otherwise, it uses a loop to print every alert. The loop also prints a number before each alert to make the output easier to read. Because the security class has a two-string method, each object is automatically printed to formatted style I designed. The sort alerts method uses collections.sort. This is one of the required collections algorithms because security alert implements comparable Java knows how to arrange the objects. The alerts are sorted from lowest threat level to highest threat level. After sorting, the program calls view alerts so the user can immediately see the new order. The shuffle alert method uses collections.shuffle. This randomizes the current order of the alerts. The assignment describes this way the manager performs random audits. After shuffling, the method also calls view alerts, so the randomized order is displayed. Display extremes method finds the lowest and highest threat levels. It first checks whether the list is empty. If the alert exists, it uses collections.min to find the lowest natural order. If the collection is not matched, it finds the highest natural ordering. Because natural ordering is based on threat level, these methods return the lowest threat level to highest threat levels. The program then prints both alerts. This method is called when the user enters done. It creates a file named threat log text. I use a try with source statement from a formatter object. This prevents the resource leaks and helps